Alright everybody, here is a little overview of what I hope you were working on for the last little while. So the assumption is that you have already gone through and attempted these questions and you have answers of your own, and you're basically just checking your answers, and I'm just sort of giving you a little pointers along the way here. So I'm going to start with question 1 here. This is a question where you're being asked to factor that polynomial. I'm hoping that you notice right away it's not a factor by grouping question. So you're going to try synthetic division. So here is the completed synthetic division answer staring at you on the left there. Also keep in mind, I'm looking at the constant on the end, and the factors you would be attempting here will be plus or minus 1, 2, 3, or 6, because those are the numbers that go evenly into the constant at the end. So I'll give you a fairly easy one to start with. 1 seemed to work, because that's what you have right there. And so then you're left with these 3 as coefficients of your variables, 2x squared plus x minus 6. Please make sure before you write your test that you are able to factor a trinomial with a leading coefficient right there. And your choices are, you can use decomposition or you can use trial by error. But either way, you have to be able to factor it into these 2 factors. Okay? And please make sure also that you understand the directions to the question. When it says factor, that you can't go any further than this. You can't give answers when a question just says factor. These are the 3 factors of that polynomial. Part B of this question, I hope you noticed it was the same polynomial again, so you didn't have to do a whole bunch of work. The difference is the directions to the question. Now it says solve. So this factor here leads you to the 1, this factor leads you to 3 halves, and this factor should have led you to a negative 2. And then we are looking at being able to graph that polynomial, and the intent is that you need to be able to graph it by hand, not that you're able to punch this into your graphing calculator, because remember, you don't have a graphing calculator for your test. So I would have probably expected the first thing you put on your graph would have been your x-intercepts of negative 2 and positive 1. So there's your negative 2, there's your positive 1, and then this one here is 3 halves. Remember, 3 halves is 1.5, so it should have been halfway between 1 and 2. Your y-intercept you can get from the non-factored version of this equation. It's positive 6, so you can put your y-intercept on there. Looking at the leading coefficient, it's positive, which means it goes up to the right, so we have that. The degree of this polynomial is 3, which is an odd number, so you know it goes down to the left because it has to go in opposite directions as to the other one. And each one of these factors occurred only once, and so you know at every x-intercept it just passes through the x-axis, and so you just draw your polynomial. This question D comes from your graph. It says give the intervals where it's greater than or equal to 0. So again, you're looking for where it is above or equal to the x-axis. So you have the loop, which I'm going to put little train tracks on right there, and that is everywhere between negative 2 and 1. And so that's how you say everywhere between negative 2 and 1. And then it is also this part here, which is everywhere to the right of 3 halves. So you say x is greater than or equal to 3 halves. Okay. Now, question 2. What I want to focus on when you're doing these questions is the directions to the question. It says to find k, but this question deals with remainder. So anytime you see a question dealing solely with remainder, I want you to be thinking about remainder theorem, which means plug a number into an equation. So you're dividing by x minus 4, so this was meant to be a question where you simply take the number 4 and you substitute it into this equation. And remember, it says the answer to the question is 6, so it equals 6, and then you just do your arithmetic and solve it. Okay, and I assume you guys are able to do the arithmetic. Question 3, it asks you what are the possible roots of this equation. Please remember that it's not just plus or minus this last constant here. I mean, yes, that's part of it. Here's the plus or minus 1 and 5. But remember, the actual way to find all of the roots is called the rational zero theorem, which means it's all of these factors divided by all of the factors of your first coefficient. So that's why you have this big long string of numbers, because basically it is every combination of plus or minus 1 or 5 over plus or minus 1, 2, 3, and 6, which is every number that divides evenly into 6. Okay? And some of these are repeats, and so don't actually get copied down twice. Like, for example, oh, no, I'm lying to you. There are no repeats, and so all of them get copied down. Okay. So, moving along, number 4. Again, please pay attention to the directions to the question. They are factor as far as possible, but then you also have to get answered. You have to solve it. So I'm hoping you recognized right away this was not a factor by grouping question, so it was synthetic division. So what you want to do here is use your synthetic division. It looks like 3 was a factor. Sorry, 3 was a root, and so you do your synthetic division and you get this. Hopefully you recognize pretty quickly that this second part here, x squared minus 4x minus 7, did not factor. And if it just said factor, you would have been done. But it said solve, and so that's why this now leads into the world of the quadratic formula for that section. Remember that I'm looking on your test for not decimal answers, I'm looking for exact values, and so that turns out to be the exact reduced solution to this quadratic formula. Okay? And then make sure when you write down your answers, remember that it had an initial value here of 3, remember that one, and then you write your answers for the quadratic formula. Okay? Number 5, divide using long division. So yes, you are responsible for long division for your test. I'm not going to go through how to do long division, but I just want to point out a few things about what we're doing here. This is what you start with. Your first polynomial, okay, 2x to the third plus x squared minus 2x plus 1. So that is called the dividend. This is what you're dividing by, and so it's called your divisor. And your answer up top is called your quotient. And I'm going to point out that you're also responsible for what a division statement is. And so a division statement is either how to get the initial polynomial, is you multiply the quotient with the divisor and then you add on the remainder, or it's a restatement of the question. So I'll let you guys take a look at that, but you're responsible for both methods of the division statement. All right, number 6. Let's take a look at what the question actually says. It says find A and B if the remainder, and again this question is talking about remainder. Okay, so it says you're dividing by x minus 2 and you're getting an answer of 7. And so as soon as you see you're dividing by x minus 2, you should understand that you're plugging 2 into the polynomial. And you keep going as far as possible with that until you get a simplified equation that is simplified as much as possible. So you get something here, 2a minus b equals 7. That's the simplest form of that one. And then you do the same thing again. It says you're dividing by x plus 4, and so you're going to be plugging negative 4 into it. And just be really careful with your arithmetic. And you will eventually get down to a stage where it says over here, 4a plus b equals 23. And then this is a reminder, we did a couple of these questions earlier. This is where you have to put these two equations together into what's called a system of equations, where you write one on top of the other, and then you get your solutions. All right. Now, number 7. Here's the meat and potatoes of the chapter. Find the equation of a polynomial that has zeros of negative 3, multiplicity 2. Hopefully you remember that from last period. It means that you're going to have a factor of x plus 3, and it's going to show up twice. That's what multiplicity 2 means. And you're going to have a factor of 2, and so, a root of 2, and so you have a factor of x minus 2. Remember, what you're looking for in this question is you have to find this value right here, this a value, which goes in front. And they give you one other piece of information. It says the y-intercept is negative 18. Just a reminder, that means the point is 0, negative 18. And so you put 0 in for x, you put negative 18 in for y, and then you solve that equation for your a value. This one works out quite nicely. The a is just 1, and so when you write down your final answer, there's just a big 1. 1 out in front of your polynomial. You're always going to be asked to find that value out in front. Then it said sketch a graph. I would suggest that you're putting the -3 on your graph first because that's one of the roots, and then you're putting the 2 on next. Those are the only x-intercepts. This question had a positive leading coefficient. Remember, the leading coefficient was 1, and so it goes up to the right. This question had a degree of 3, because if you count your x's, you have an x squared there and another x there, which leads to 3 of them, and so it's odd, which means they go in opposite directions. A reminder, this factor right here occurs twice, and so it bounces at -3. And then the y-intercept was given in the question. It was -18 way down there, and so you just draw your polynomial. Okay. Number 8 is exactly the same idea as number 7. The only difference is they don't tell you what the y-intercept is. You have to read it off the graph. So I would look at this graph and say, here is an x-intercept of -2, and then look at your equation, which means there's an x plus 2 in the equation. This has an x-intercept of +2, so there's an x minus 2 there. And when you look at your graph, it bounces there, and so you know that it has to occur twice, and so you put your exponent of 2. The only thing that's missing in this question is you don't know what your a value is, which is what you need to find. And the way you're going to find it is by using the y-intercept. This is 0, 4 as your y-intercept. And so what you're going to do is you're going to plug those values in for x and y. So I plugged in 4 for y, and I plugged in 0 for x, and then you just do the arithmetic and solve for a. Looks like you get 1/2 for a, so there's your answer. Okay. And the last question, probably the most important question on the sheet, is solve this polynomial. And I want you to really be careful when you write your test, understanding that this is a long question because of the fact that there's an inequality sign there. It's not an equal sign. So this is a question where you have to factor it, and you're going to use synthetic division. I'm going to assume you guys are pretty good at factoring, so I'm going to assume you were able to get way down to there. Now, when you look at the factored version here, gives you the roots. So you have a root at -1, you have a root at -4, and you have a root at +2. So you put those on there. This polynomial had a leading coefficient that was positive, so it goes up to the right. Degree was 3, which is an odd number, which means you go in opposite directions, which means you go down to the left. And every one of these factors occurred only once, so it just passes through each time. And so that lets you draw the graph. You need to draw the graph to get your answer. There's no way to just get your answer from the equation. So once you have the graph, now you look to see what the question actually asks you. It asks you, where is it above the x-axis? So it's above the x-axis in this little loop right here, which looks like it's everywhere between -4 and -1. So that's the first part right here. Also, please keep in mind that these do not have the little greater than or equal to's under them because the question didn't have it. And when I look at this graph, I also see this second part out here, which is above the axis, and that's everywhere to the right of 2. And so that is this statement right there, x is everywhere to the right of 2. Okay. Anyways, I hope this helped. Good luck on your test next period.